few weeks ago, I printed a Rubik's torture cube that had all sorts of crazy parts that included very detailed prints, thin walls, and functional parts. Now, if you don't recall, you can review that video here. Now, with the settings I used, the majority of the parts met expectations, except for the functional parts shown here. One was a ball on the end of a stick shown here that fit in a cup that should have rotated. I refer to it as the ball cup part. Another was this hinge where I believe I measured less than 0.3 millimeter tolerance gap between the rotating parts on the model. And another was this threaded bolt that should have moved up and down, and the gap in the model was also less than 0.3. And lastly, these set of gears, which the model shows only like 0.2 millimeter clearance. So I didn't expect actually an SLS machine, which mostly are rated to meet a 0.3 millimeter gap tolerance. I really didn't expect these parts to work. But at the end of that video, I said I would investigate a little to see if there were any settings I could adjust to improve on the tolerance between the gaps. Now, I didn't see this tightness issue just on these functional parts on the Rubik's torture cube. I had also seen this tightness between parts on these fidget cubes after printing, where the gap was between 0.4 to 0.5 millimeter. And I kept measuring part densities over 1 gram per cubic centimeter. So in essence, I felt I was over-centering my parts, almost too much energy, and they caused me to lose the ability to maintain a 0.3 millimeter tolerance gaps. So in my discussion with Thomas, they said that the default energy density found under the print profile power could be driving these issues. And there are 3 energy densities found in the print profile: outline energy, in outline energy, and fill energy. Now, Pavel said it's best that all 3 are changed at the same ratio if you make any changes. Now, as you can see, these 3 default values, 24, 18, and 15, they were originally set by Pavel and Thomas when they were experimenting and operating under lower print layer temperatures. They set around 174, but as they increased their print surface temperatures, closer to 177 to 180, they basically said that maybe the laser energy density may not need to be as high. So to find the optimum laser energy density values, I used the profiling print job feature and some standard tolerance cylinder models like these. Now, the tolerance cylinders are labeled with a gap in millimeters between the fixed outside cylinder and the rotating inner cylinder. There are slots in the back, so after printing you can take a blade screwdriver and turn the cylinder to loosen it. If it moves, it means you can print at that tolerance gap. The profiling feature is pretty cool when you want to study the impact of changing certain print profiles but during the same print job. So to do this, you're basically creating zones on the print bed by designating parts by rows and columns. So I set up the first test with 5 tolerance cylinders laid out with the top row with 2 columns, a middle row, and a bottom row with 2 columns. So for me, I wanted to print at the default energy densities of 100% and then decrease by 5% across the cylinders, where the last one was printed at 80% of the default energy densities. And then I printed 5 more, starting at 85% of energy density and decreasing to 65%. So let's study the results of those prints. All right, so let's take a look at the results from the tolerance cubes. So as you can see, each one of these tolerance cubes, they each have, they're labeled here at 0.5, 0.35, 0.3. So that's basically the gap between this and that cylinder around it. So after you print it, and there's little screw holes on the back, slots to turn it. If it turns freely, so this one happens to, this is at 100% default energy. And if it turns freely, it means, okay, I can print, if I print at this energy density, then I can at least meet a 0.5 millimeter gap. Unfortunately, and that's why, when I did the torture cube, I've done some of, my fidget cubes, things were getting tougher. And I tried to move that 0.3. You can see I torqued on that pretty hard.
and I couldn't get the 0.35. So at 100% default energy density, with all my other parameters set, the best I could do was maintain a 0.5 millimeter tolerance between functional parts. So then I did a 90% as well. So obviously the center one moved there, and the 0.35 actually started moving there. So, and then I tried to crank on the 0.3 and it just would not budge. So, so we got improvement by lowering our energy density. And I'll show you a wrap up on a little file here on the results from everything, including dimensions and densities. But just kind of give you an idea, I actually saw decreasing density of the model as I decreased the energy density, which makes sense. But overall, the quality of these cubes all looks still really, really good. All right, so if we look at the 0.85 part, we're able to get the 0.5, obviously. We've got the 0.35, so it moves in there. You can see it moves a little tight. And then the 0.3 took a little more effort. It's tight, very tight, in fact. So at 85%, I finally got the 0.3, but you can see it's the slot there. I cranked on it pretty hard as well. So we were just starting to get to the 0.3. Now in SLS, in technology, they say 0.3 is what you should design through. 0.3 millimeter is the design tolerance. But that was so tight, and I didn't want to have to, if I'm printing functional parts that maintain a 0.3, as you get powder in there that's unsintered powder, it's hard. I just didn't want to have to, it takes a lot of effort. So if I take a look at the 80% energy density, you can see then here the 0.5 move, the 0.3 move, the point, when I look at it, it was probably, you can see it didn't take much to break the 0.3, so it moved. You can see it move in there. I got a key that I'm using, and I forgot my screwdriver to show you this. But it moved. It took a little bit of effort, but it wasn't as tight as the 0.85, which is what I suspect would be the case. So then we take a look at the 0.75. 0.5 obviously moves really well. We'd expect that. The 0.35 moved really well. Actually, the 0.3 actually was moved probably better than all of them. So it was, I'd say it was moderate at best to get it to move. I could not get the 0.25 to move at all. So at this point, I feel like we're getting close to where we need to be at, but I obviously went to the 0.7 and was part of the group that I printed. I got the 0.35 and the 0.3, moved pretty, once again, it took a little bit of effort. You can see the slot. So there really wasn't a lot of difference in terms of, I would say, 0.75 seemed to be better actually than 0.7 in terms of getting it to move, but maybe that was just a feel. And once again, the quality of the parts still looks good. They feel sturdy. And then the last one, 0.65, actually, as you'd expect, everything should move up to the 0.3. In fact, the 0.3 moved very easily. I said moderate, and I actually got the 0.25 to move. I mean, it actually moves pretty good. So overall, this printing at 65% of the energy density, I was able to get all the way down to a 0.25, where 0.3 was moving pretty good. We don't need to be at 0.25 in terms of designing, but it was just kind of good to know maybe I could go lower if I needed to in my energy densities. Now I will tell you the overall density of this part here was about 0.95, so that's around Formlab centered PA12. So I wouldn't think the properties would be significantly impacted. Dimensionally, all these really were literally like within 0.2 millimeters of the spec in terms of depth, width, and the XYZ directions. This part, I see the 0.75 is around 0.98 density, and I mean literally dimensions were just spot on. So now, because of how these were printed in the bed, I would think that there's some variations in how the laser and that distance could partially be impacted by the position as well. So in discussion with Thomas, he felt like I shouldn't go below 0.85. He felt like, I met the 0.3, although it was extremely, I had to really crank hard to get that to break loose, because he was afraid that the mechanical properties and the ability to do thin walls would be impacted if I went lower. And of course, I'm a curious person, and I wanted to actually test to see if that would be correct. So what I decided to do was then, now that I kind of know where I can operate and still make good parts, lowering the laser energy density during the fill and outline phases, I decided then to get basically 3 different parts. So I wanted to print, if you recall from the Rubik's Cube video, I printed this what I would call kind of a lattice structure. And if you really want to test thin walls, well, this is a good one to do. It has 0.7 millimeter thickness in each one of these lattice structures. So I printed those for all 3, and I believe this was the 0.75. I've got them all labeled on there. It's 85. So I printed these. So this lattice, if you push on it, on the edges and everything, I mean, this is pretty strong, right? I mean, it has that nylon, has a little give to it, it's a toughness. Doesn't feel brittle. The 80 is the same way, and the same thing. I was actually a little unfair to the 75 when I was doing the testing, but you can see I'm pushing on that pretty strong. And but I was actually then putting pressure on the edges, and it did break there because there's not a lot of, I would say, there, but I did the same thing to the others as well. But I was being a little more unfair on the 75. I just wanted to see if it was mechanical properties just by feel were impacted. To be honest with you, I did not see any difference between the 85 and the 75. In fact, when I look at the, and I can show you here, that actually kind of, like I said, location on the print beds probably has an impact on some of the results. But the overall densities of these parts, this one was around 0.96, and these were a little bit higher. Actually, this one was around the 85 was actually 0.96, and this one was the heaviest, and this was printed in the middle of the bed. So this was a good way to see thin walls, and I didn't see any impact. That was my biggest concern, is if I go down to 75, am I going to see an impact on thin walls? And I'm going to do some more objects with thinner walls, more solid parts, see if it feels brittle. But for now, this seemed pretty clear. The other ones were these fidget cubes. And to be honest with you, I labeled these, but I don't want to waste the time showing you because it really doesn't matter. This is, okay, well, this is the 85 and 75. Okay, so when you look at these, now the fidget cubes, one thing I liked about these, when I initially printed these in the beginning, when I had the fogged up galvo window, I actually printed, they came out and I was able to move them right away. They were easy, nice, flexible. But then once I got all that cleaned up and cleared up, after I started printing more of these, and they were really stiff. I mean, I had to really work to get those to break out. And that's when I started realizing I felt like I was over-centering, let's say, and I just was not getting the clearances I thought I needed. And so that's now, at all 3 of these all came out and worked really well. In fact, once again, if you look at the data on these, the overall, the density of this one was 0.98. I think this one's around 1. This one is actually lower. This one, it was in, because this one's in the top right. And it actually was the lowest density, which was, surprising. So I think, once again, I think there could be a difference in terms of where it's at on the print bed by a little bit. Overall dimensions, once again, they looked really, overall looked really well. looked really good. In fact, the dimensions on this one, lengthwise, was about 0.5. It was further off than the others. That was at 85. So 75, once again, doesn't look like I have any decrease in quality. When you get up close and look at the grains and stuff, it looks fine and it's solid. You know, I mean, all this stuff, I mean, you can really pound on this and it won't break. Okay, and then the last, I wanted to do something that had a 0.3 millimeter tolerance. So, so these parts are broken, and I'll tell you why. But this one's not, and this one moves, and it just so happens to be 0.75. So it did take a little effort. I had to, you know, I just had to put clamps on both of these and kind of just got it work. And once it worked, now it's really, really feels really loose in there. The mat, it has a 0.3 millimeter gap, and so it moves in there well. So that was another piece of the Rubik's that I wasn't able to get when it was at 100%. Now it makes sense now. These, I put on those pliers and tried to move back and forth. It never broke free, broke off the handle, and same with this one. So I'm beginning to think that I need to run all my future prints now at 75% of the default energy density, and that includes the fill and the outlines, to really kind of maintain the tolerances that I need between parts and still keep the integrity of the overall strength and integrity. So I'm gonna do some tensile bar prints and really see if there's any drop off in mechanical properties. I don't have a tensile machine, so I may have to rig something up. But overall, I think in terms of settings for me, and it has to do with my surface, print surface temperature is at 177, and with these energy densities, then if I run at 75, I'm running good parts, and I think that's where I'm going to go forward. I'm going to do some more prints, and if I find anything that tells me different, then I'll let you all know. So as far as printers say, there's some room in the energy density, especially if you're having troubles with tolerances. Okay, well, that's it for this print setting, and we'll stay tuned for the next one.